Alright, so the mechanism we want to be examining next is this one. So basically, it's some sort of embossing device. You put a seal in here and crank down on the handle, and basically it applies a large force to the seal that you're trying to emboss. So the question given is that we have we know that the vertical force exerted on the seal is 900 newtons. So basically, you need to press down on it at least 900 newtons in order to cause the seal to be embossed in the middle. So you're pressing that hard. Based upon that, what force are we going to be applying at P? And then what's the reaction at A? So one assumption we're going to be making here is that it's got this little sleeve here that the embosser kind of goes in, and then that's connected to the handle by a 2-force link. So we're making the assumption here that the guide here that the seal sits in, that it allows the embosser to move up and down freely, but doesn't allow any rotation and doesn't allow any lateral movement. So basically what we're saying here is that whatever force kind of gets applied by BD here, it's going to be kind of like canceled out completely, other than the vertical direction by the thing surrounding E. So we're really only worried about how much force we need to apply down here. So if the vertical component of FD is known, then obviously that means that the vertical component kind of this link's known. Then that means we also know the vertical component of the force in this link BDE. This link BD here. So based upon that, so again, this thing isn't under tension. It's under based upon this, our initial assumption is that it's under tension, but instead we've got a vertical force pressing on there. D is pressing down on E, which means that this thing is under compression instead of tension. So we're going to again denote that with a negative sign. So the y component of the force in BDE is negative 900 newtons. It's pressing downwards. So we know that we can basically, and this angle here between here and here, that's 20 degrees. So that'll be that'll basically allow us to solve for what the force in BDE is based upon the cosine of the 20 degrees. So just take our 900 divided by cos 20, gives us 957.75 newtons. And again, that's compressive. And then from there, we can just go ahead and find what the x component of that force is as well. We're going to need that later. So again, just take this, multiply by the sine of 20, and that'll give us negative 327.6 newtons. So I just drew a quick free body diagram sketch of this handle here. So now that we have resolved what these two forces are, then we have left with three unknowns. So got AX, AY, and P. So three unknowns, three equations. That's doable, right? So we're going to go ahead and draw more. I'm just drawing a larger, more detailed diagram of the handle so I can get the dimensions there. So again, and that's just based upon the fact that we knew that the angle from here to here was 60 degrees, and the length from here to here was 200. And then the angle from here to here is 15 degrees, and this was 400. So we can go ahead and fill in the rest. I'm not gonna bore you with the details because I'm sure that most of you remember your basic high school geometry. So we're able to kind of break this up into the x and y components of the x and y positions of where these forces are applied. And I just went ahead and subbed in, directly placed in what our AX is going to be, because there's only the one other force, so it's pretty easy to do the sum of the forces in the x direction there. And then for the other two unknowns, we got two equations we can work with. So first off, we're going to start with taking a moment. So I took the moment about A, so about this point. So that'll just be P times this distance here, the 486.4, and that'll be a negative moment because, again, that'll cause a clockwise rotation. And then we've got the two components of the force from the forces from the link. So we've got 900 newtons crossed with the 100 millimeters, and again that'll be a positive rotation. Sorry, a positive moment, counterclockwise rotation. And then we've got the 327.6 newtons crossed with the 173 distance here, and that'll also be a positive moment. So then we just multiply those together, and then move the p term over to the other side, divide by that distance, and we're able to get solve for our force P. So basically that's the entire point of the handle here is to give you some leverage so that you don't need to apply as much force as what's needed to emboss the seal. So in order to press down on the seal with 900 newtons of force by the embosser, you physically need to push down on the handle with 301 newtons of force. And of course, if we got a longer handle, then that amount would be decreased even further. So we got that. The only other unknown we had was the AY. So just take the sum of the forces we'll just take the sum of the forces in the y direction. So AY is equal plus 900 minus P, so minus the 307 is equal to 0. So AY is equal to negative 900 plus 301.7 newtons, which gives us a negative 598.3 newtons. So our reaction at A is actually this way, which makes sense. I mean, if you're pushing down on this one side, then in order to balance out, based upon the fact that you're basically pivoting about this point, then you also got to push down on this side too. So that works. So that's a relatively simple machine. The entire point of machines, as I mentioned in the lecture, is basically to transform forces to be able to multiply the forces, or to transfer where they're applied, change their type of movement or rotation. So you can change a linear force into a rotational movement of some sort. But in this case, we're applying leverage in order to multiply the force that we can apply. So yeah, that's that.